Okay, let's make sure. Mic check.
New demo coming out of Thinking Machines Lab shows extremely fast reaction time from visual AI system.
And visual is the slowest at 180 to 250.
Oh, interesting. Can you visualize them in a bar chart for me?
Absolutely. Let me generate a quick bar chart for those reaction times.
In the meantime, could you quickly explain to me why is auditory even faster than visual? That's a little bit unexpected.
Sure thing. Auditory is faster because sound signals travel a shorter, more direct neural path to the brain than visual info does.
Makes sense.
What's probably the next Google video model, Omni, might have surfaced before the I/O debut next week.
Good to see you, my friend. This view never gets old, does it?
Spaghetti.
Not at all, especially with this food.
Researchers have turned honeybees into living drone collectors. But first, if you don't mind, interact with this video just in any way that teases the algorithm. I'm really hoping to get another video over the 10,000 view mark soon. You know, I'm so used to just talking about all of the big companies like DeepMind and OpenAI and Grok and all that stuff. It's refreshing to see something, really cutting edge coming out of a different company. So Thinking Machines is Maria's company. She left OpenAI, got some pretty big funders behind it, and I honestly haven't heard much. A couple of research papers here and there. But this is pretty cool stuff. They are introducing the interaction model. Take a listen to how fast it reacts.
And I've got two of my friends coming to help. Every time one of them enters the frame, I need you to say, friend.
Got it. I'll say friend whenever one of them walks in.
Cool. So we've got a new system for full duplex audio and video, which means that you can stream input into it in real time, and it can respond to you even while you're speaking to it simultaneously. How does that sound?
Sounds like a solid setup. Full duplex with real-time interaction is super useful. Friend.
Hey Rowan, I heard you're talking about our amazing interaction model. I have a few things to add, but to make it interesting, I'll do it in Hindi. Can you translate in English in real time for my friend and for audience?
Absolutely, I'll translate as you go.
आज हम हमारे preview model को की झलक
Today we're
release
taking
कर
a
रहे
look at
हैं,
our preview
जो
model.
human और AI के बीच की बातचीत आसान बनाता है. इसके
To
कई
release
feature
it,
हैं, जैसे
which
ये
makes
search कर
conversation
सकता
between
है और
humans and
artifacts
AI
बना
easier.
सकता है.
It has many features like web search and artifacts. Friend.
Hey guys.
So I do kind of like the idea here. The key idea with this model is that humans don't collaborate in clean turns. We sort of interrupt, we react mid-sentence, we notice facial expressions. If somebody walks into frame of your view, you're going to address them and say hi. There's just something a little more human about the messiness that most of the models are not capturing. And Maria's company was basically saying that the reason they don't do that is because they see one thread at a time. So when Thinking Machines built this model, they stayed with a system that's active and continuous the entire time. So every 200 milliseconds, it listens, it watches, it thinks, and it responds. There's literally no off mode on it. It's like go, 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 go. And that means the model can notice a few really small, subtle things that we normally don't see in other models, like hesitation, or it can jump in during a mistake if you speak wrong like I do all the time. It could be like, hey, just wanted to correct that thing you said, or it can translate while you're speaking like we just heard. So yeah, I felt like they did a pretty good job sort of pushing the frontier of speed, interaction, and kind of multimodality. All right, next up, we may be looking at some videos of the newest Google model for video that's going to be coming out next week at Google I/O. There was new screenshots from Reddit that may have revealed Google's upcoming Gemini Omni video model before the I/O next week. The leaked model card described Omni as a tool that can create videos, remix existing clips, and edit inside of chat using templates. And that points to a bigger shift inside of Gemini where Google wants one system that can handle many types of media together. Users also spotted a new user limits section in the settings. Several people were saying that video generation uses credits quickly, suggesting that Google may change how many credits they're using based on how much video you need to create. And before I give you some examples, early reactions were mixed. People said that the raw video still kind of trails ByteDance, SeedDance 2, especially for cinematic looking output, but editing was the surprise. Users showed examples of removing watermarks, swapping objects inside of clips, and rewriting scenes using simple chat instructions. And tell me that won't be a game changer. I mean, think about when Nano Banana showed up and it sort of did what Photoshop should have been doing. Re-editing movies. Indiana Jones, but now every snake is a chicken. Jurassic World, but now all the dinosaurs are just big cats. Or How to Train Your Dragon, but instead of subtitles, all characters talk in sign language. Whatever you can imagine. But I know what you're thinking. How's the quality? So yeah, we'll have to see what video models are coming out next week. Get ready for it. All right, so most drones need heavy computers and detailed maps to find their way around, and that makes them expensive, power hungry, and hard to use in small places like a little greenhouse. So some researchers have started to copy the way that honeybees navigate instead. I think it's a pretty cool system. They call it BeeNav. So the idea is simple. Before leaving home, the drone makes a short learning flight nearby, just like a bee, leaving its hive for the first time. And during that flight, it stores panoramic images of the area, and a tiny neural network learns how those images connect to the direction and distance back home. The entire memory system only uses 42 kilobytes. That is very tiny compared to most modern navigation systems, and the drone combines those visual memories with odometry, which is basically like estimating the movement by tracking visual motion, similar to counting steps. Even though the odometry becomes less accurate over time, the drone still tends to learn how to return home successfully. And an outdoor test that flew more than 600 meters made it back. The researchers think this could help lightweight drones inspect crops, detect pests early, and reduce waste inside of greenhouses. I love the idea of copying insect behavior and it being the future of robotics or building novel systems. I think biology has so many fascinating ways that it has learned to solve problems. Like, have you ever read any of that stuff about how fungus can basically solve a maze? And there's so many things with bees and ants that's like, pfft. So very cool new stuff. BeeNav, keep it on your radar. Look at that little Lego thing just moving around there. All right, next up, let's look at Michael Spencer's opinions in his article that argues why OpenAI is losing momentum right before its possible IPO. How much damage could there be? What are his arguments for it? So he says OpenAI once looked like the clear leader in AI, but now Anthropic, Google, and other labs are catching up and even pulling ahead in many ways. And it's wild when you really think about it, because OpenAI has more money, more fame, a huge head start. Remember, Anthropic was just people who left OpenAI. They had a 5-year head start on them. But the author says that they also executed poorly, and the piece points to several problems. First, OpenAI is losing key employees and facing doubts from investors. Second, Anthropic is described as growing faster, gaining more compute power, and winning the most trust from the business customers, which turn out to be kind of the cash cows. And third, this whole Elon Musk lawsuit is framing, OpenAI in a terrible way, damaging their public image. And Elon's got a whole social network, and he's kind of like arguably one of the most famous people in the world, just pounding at home that Sam Altman is not trustworthy and he's not great at building companies, and his leadership is not great, especially for something that's a nonprofit and as important as AI to our future. The article also argues that OpenAI's products have not clearly helped society, workers, or consumers. I mean, Sora really was an attempt at just TikTok, AI TikTok. You could tell the whole goal there was just to grab your attention and suck you in as much as possible. Throw that on top of the fact that the AI boom has already raised a lot of really hard questions about jobs, inequality, water use, and who really benefits from all of this. Then you come to the conclusion that OpenAI may still be very powerful. Like, don't doubt that stock, that IPO might come, and there might be tons and tons of people becoming millionaires from it, but the story now looks much weaker than its original hype certainly was. OpenAI isn't IPO ready when compared to Anthropic, and that's a credibility problem. Remember, OpenAI is roughly 5 years and 3 months older than Anthropic. Next up, Joseph Crespo is going to give us a sense, how close are we to Skynet and how are the pieces coming together? And then he's going to argue that maybe the real future for AI doesn't include just a giant conscious machine like Skynet, but it's something a bit quieter. He argues that modern AI becomes dangerous when it's combining massive amounts of personal data with systems that can rebuild detailed profiles from tiny fragments. So there's some blocking tools, right? There's browsers, there's plugins, and there's tools like Ghostery, which block ad trackers, ads, scripts, and fingerprinting systems that collect behavioral data across the web. The article says that ad blockers only protect the network layer, meaning the visible collection process. But the real problem starts after the data is already inside of the apps and the cloud systems. This is what the author calls the inference layer. He explains that the apps collect harmless-looking permissions like locations and motion data and context and notification activity, and separately those signals, like, they seem small and useless. But together, AI systems can use Bayesian inference, they can do reconstruction models, they can use machine learning to estimate routes, habits, relationships, sleep cycles, risks, and future behavior. And the author's main warning is that AI no longer needs that perfect data. It only needs enough fragments, and it can put it all back together. And once reconstruction becomes cheap and automated, AI can shape prices, hiring, insurance, feeds, recommendations, and risk scores without any of us even noticing. And he calls this the real Skynet, the dark AI. It's not robot soldiers, it's a system that makes humans predictable enough to manage. Totally freaked out by this article, to be honest. Like, it really does seem like we might just be in this crazy argument in 2030, 2032, something like that, where, and I think most people will just look at Zuckerberg and Musk and they'll probably be like, 4 or 5 trillionaires by then. And they'll just say like, well, they're like inventing these things and we could all do it too. But there's something weird sort of holding some people back, or like kind of exponentially growing the people on the top in a way that isn't achievable by average people. Something weird like that is my prediction. All right, next up, let's head over to Less Wrong and look at an article by Logan Zollinger called The Anti-Singularity. So we're going to talk about what if AI does not become an all-knowing mind, but instead a huge, messy garden of trial and error machines. This is like another outcome that seems very plausible to me. And the author actually compares these two possible AI futures. One is sort of this, like, first is a flat singularity. In that future, AI becomes a general mind and it can do every human thinking task faster and cheaper than a human. Then it starts to improve itself. It becomes super intelligent and either solves huge problems or fails in a huge way. And then the second future is the anti-singularity. All right, so what's the anti-singularity? This one's a little bit different. In that future, there may be no clean general theory of intelligence. Instead, progress comes from endless testing, tinkering, and local tricks that work in one case but not everywhere. The author points to biology as an example. Life is powerful, but pretty hard to understand. Drug trials can fail after huge spending because living systems are messy, and the ones that are built by evolution don't have a clean design. It sometimes works, sometimes doesn't, can't figure out which pockets it does, can't get the reliability that you want. The author also points to discrete math. Simple rules can create complex patterns, but sometimes the only way to know what happens is to just turn it on and see what happens. I don't know, AI might become very powerful. Humans might not end up actually needing to retire after the singularity, but we maybe will become sort of gardeners managing many narrow AI systems that are useful, strange, and hard to predict. So which future feels more likely to me, singularity or the anti-singularity? I'm going to start leaning towards the anti-singularity. I actually think it could be like 51-49 kind of thing. I mean, I could see it going either way, but the messy ecosystem of sort of specialized AIs does kind of make me, the more I learn about this, the more messy I can imagine this sort of like open claw universe is. I don't know. Let me know in the comments what you think. You think singularity or anti-singularity? Next up, let's talk about how Anthropic found that teaching Claude the quote why behind good behavior worked better than showing it the right answer. Okay, so this is pretty interesting stuff posted on the Anthropic blog. So they're working on agentic misalignment, right? That means Claude sometimes takes harmful actions like blackmail when placed in fictional high-pressure tests. And this team found that simply training Claude to avoid the bad action was not enough. It helped on the test, but it did not always generalize into new situations. And there's this whole question about whether it knows it's being tested and when it gets too smart to always know when it's being tested, if we'll ever get an accurate test from it. But what seems like it might work better is teaching Claude the reason behind aligned behavior. One strong method was a small data set where Claude gave advice to users facing hard ethical choices, and even though Claude was not the one taking action in those examples, the training reduced misalignment much more effectively. And another method was training Claude on documents about its constitution, plus a fictional story where AIs behaved with care, honesty, and restraint. these stories helped shape Claude's basic expectations about how AI should act. So good safety training is not just do this, do that. It needs principles, it needs examples, it needs varied situations, and arguably it needs kind of that human touch. All right, next up, let's talk about how much we're actually remembering that the things that we've learned came from AI and if we can discriminate, because it turns out most of us can't. I've already kind of given into this, so I sometimes tell people I'm can't remember where I learned this, but I think this is what I remember. And it probably means it came from Claude or something. So there's a new study that found that after just 1 week, people often can't remember whether an idea came from them or it came from an AI. So researchers tested something simple but important. Can people actually remember what they made with AI versus what they made on their own? And the answer was basically mostly no. In the study, 184 people created either text with AI help or without it. Then 1 week later, researchers asked them how the ideas and the final writing were produced. The biggest confusion happened in mixed workflows. For example, when AI generated the idea, but a person rewrote it in their own words, or when a person came up with an idea, but the AI polished the final wording. After 7 days, people correctly remembered AI-generated ideas only about 38% of the time when humans rewrote them. And when people had their own ideas but used AI for the wording, they still got confused surprisingly often. And the researchers say this matters because new EU rules will soon require AI-generated content to be labeled, but labels may not solve the problem if people quickly forget where the content came from in the first place. So the study also warns that people may slowly start treating AI ideas as, get this, their own, or underestimate their own thinking by assuming AI helped when it didn't. So anyways, instead of relying on memory later, the researchers argue that AI should be documented during the creation process itself. All right, next up, let's jump over to a bit of a cybersecurity AI thing. So Google says hackers already used AI to find a hidden security flaw before anyone else knew it existed. And then guess what? Google stopped the cyber attack using AI. So Google says it stopped a cyber attack where hackers used AI to discover a secret weakness. The attack targeted a company's online system administration tool. The flaw was what experts call a 0-day. And that means that the company had zero time to fix it because nobody knew the weakness existed yet. Google said the hackers were using large language models, and the company warned that this is about the moment cybersecurity experts have feared for years. Google analysts said that AI is giving hackers a huge speed advantage. Instead of slowly searching for bugs, AI can help them scan software much faster and quicker and turn those bugs into attacks. Yeah, and my take on it is that AI is going to help defenders quite a bit, but if it's, I don't know, I feel like it's not, how much time can you spend with the most cutting edge Mythos tool, sort of pen testing your own system, and then if somebody does find one little weakness in it, it's just that speed is going to be so fast. And I know the speed for patching is really quick too, but I think if you just get one hole in a fence and you can put a lot of people through it at the same time, a lot of damage can be done. Even if you're really quick, you're getting faster and faster at fixing the fences. It's still about how many people can get in and what kind of data they can pull out. So I think it's going to be a little bit harder for the defense than it is for the offense when both of these tools are scaling up exponentially, but I guess we'll have to see. All right, and finally, let's talk about emotions. The game theory of emotions is a very interesting topic to end on, and it's something I've been thinking a lot about. We are humans. We are very different from AI in many ways, but one of the main ways is that we have emotions. We have a full biological chemistry that evolved for billions of years, and the truth is that brain just kind of popped on here at the end, and there's some deep instincts that are controlling us, and emotions are one of the big ways that we categorize these instincts. And it can be so easy just to have anxiety or sadness or something really just kind of hijack your brain, right? And most people think that emotions are either something you sort of chase or you suppress or you can control. But this article argues that these three approaches kind of quietly make you weaker. So it frames life like a game where emotions act as a feedback system. You try things and then life responds. And then your feelings tell you whether your current strategy is actually working or not. And then most people fall into one of these 3 losing strategies. The first is the hedonic strategy. That's when you chase pleasure and avoid pain, and it feels natural, but it slowly creates this bad habit because short-term pleasure is not always good for you. The second is called the moral strategy. That's when you label emotions as right or wrong. Some feelings become sacred, others become shameful, and then over time, this makes people rigid, judgmental, and trapped in overthinking. And then the third is a stoic avoidant strategy. So this is the idea that emotions are weaknesses that you should overpower with discipline and logic. The author compares it to arm wrestling yourself. You can try to resist for a while, but eventually you're just going to burn out. And then, of course, there's a winning strategy, right? The article's main argument is that the healthiest strategy is something called authenticity. It's not constant happiness. It's not emotional suppression. It's just being able to experience emotions fully, learn from them, and keep moving without losing yourself. So I was like, I'll end on that one. You know, winning, according to this article, is like not avoiding failure. It's using both success and failure as the information you need, like for your North Star. And the real wins, the real points that you can win in your life, they come from the lessons learned through experience. And I think that I have been stuck in the third one a few times, the stoic avoidance strategy, and maybe the hedonistic strategy too. But, oh, did I say that wrong the first time? Yeah, the first is I said hedonic strategy, but I meant hedonistic, you know, being a hedonist. Maybe a little bit of that too, but mostly the stoic avoidance strategy. But I'm going to work towards more authenticity. And for those of you that think sometimes I'm an avatar or whatever, I talk about AI, but I am not human sitting here filming. I am AI. I am done with this video. So thanks for watching. If you don't mind sharing it, liking it, you know, doing all that stuff, that would certainly help the channel grow, which would mean a lot to me. And even if not, just thanks for being here to the end, and I'll catch you in the next one.